Have you ever really wondered what's actually happening inside that box on your desk? Well, today, we're going to find out by performing a digital dissection. We're going to pull apart a modern computer piece by piece so we can understand the intricate magic that really makes it work. So, let's get started.
Our source material just puts it perfectly. When you look at all these components laid out like this, it really does look like a crime scene. And honestly, that's going to be our theme today. We're the investigators, and we're piecing together the evidence to understand how it all works.
So, this scattered scene of parts brings us right to our central question, the one that's going to drive this whole investigation. What is really going on inside this box?
Our dissection, our investigation, it begins with the two powerhouses of the whole system, the CPU and the GPU. You could think of these as the brains that do all the heavy lifting.
So first up is the Central Processing Unit, or CPU. This is the master brain, the one executing the core instructions for your programs at absolutely incredible speeds, measured in gigahertz. If we could actually crack open its protective casing, we'd find something called the die, a tiny sliver of silicon that's the real integrated circuit doing all the work.
And the scale we're talking about here is just staggering. Packed onto that one tiny CPU die are roughly 10 billion transistors. Now, to put that into perspective, each one is just a few nanometers wide. That's so small you could fit millions of them on the head of a pin. It's wild. And all these billions of microscopic switches and wires, they form what you can only really describe as a multi-layer labyrinth. It's this impossibly complex highway system that lets the computer execute billions, with a B, billions of operations every single second. It's just mind-boggling complexity that results in pure speed.
But the CPU has a partner in all this processing, the Graphics Processing Unit, or GPU. And as you can see, they're built for very different jobs. The CPU has just a few, but very powerful cores. This makes it a master of complex, sequential tasks. Things that happen one after another, like running your operating system. The GPU, though, is a different beast entirely. It has thousands of simpler cores. This makes it an absolute expert at parallel processing, handling thousands of simple tasks all at the same time. And that is exactly why it's perfect for graphics, where it needs to calculate and render millions of individual pixels on your screen all at once.
Okay, so we've got these two incredibly powerful, specialized brains, but how do they talk to each other? And more importantly, how do they connect to everything else in the system?
Well, the answer. The next big clue in our investigation, it lies in the command center of the computer, the motherboard. You can really think of it as the central nervous system, or maybe like a city grid, connecting every single component and letting them all communicate with each other. A really key component on the motherboard is called the chipset. It's basically the traffic controller for the entire system. It manages everything from your USB devices and hard drives to your Wi-Fi and your audio. It's directing this massive flow of data between the CPU and pretty much every other part of your PC. But a city grid is just a bunch of roads without any buildings. And in the same way, our computer needs places to store and access information. So where exactly is all the data kept?
And that brings us to digital memory. Now here, our investigation has to make a distinction between two key types: the computer's temporary workspace, which you know is RAM, and its long-term permanent filing system, which we just call storage.
This table really shows the memory hierarchy perfectly. Up at the top, you've got DRAM, or RAM, with access speeds we measure in nanoseconds. It is lightning fast. Then you have permanent storage. Solid-state drives, or SSDs, they're really fast, while the traditional hard disk drives, or HDDs, are the slowest of the bunch. This trade-off between speed and permanence is something you feel every day. A fast SSD means your computer boots up and loads programs in seconds, while relying on an older HDD can leave you just waiting around.
So here's the simple way to think about it, to make it crystal clear. RAM is like your desk. You can grab anything on it almost instantly, but when the power goes off, poof, the desk is cleared. Storage, on the other hand, that's your filing cabinet. Yeah, it takes a little longer to pull something out, but everything is safely stored away for the long term.
Now, all these components, they're hungry for electricity. And all that work generates a ton of heat. And that brings us to the final part of our digital dissection, the power plant, where we're going to investigate the absolutely crucial systems for cooling and power.
It's really a four-step process. First, the power supply takes that high voltage from your wall outlet and converts it into lower, stable voltages the PC can actually use. Then there are these components on the motherboard called VRMs, and they reduce that voltage even more. down to the super precise 1.3 volts the CPU needs to run. But here's the thing, this conversion isn't perfectly efficient, and that inefficiency generates a lot of heat as a byproduct. And that's where the cooling system kicks in. It uses a pump and a radiator to transfer all that heat away from the CPU and out of the case, basically keeping the brains of the operation from overheating.
So, our digital dissection is complete. We've looked at the brains, the command center, the memory, and the power plant. And what we find is what this quote states so beautifully. Alone, each of these components doesn't do much at all, but when united, they combine to form a powerful system. It's just a perfect symphony of all these highly specialized parts working together.
Which really leaves us with just one final thought. The next time you press a key or you move your mouse, will you stop and think about the billions of parts? From those nanometer-sized transistors to the sophisticated cooling systems, all working in perfect harmony in just fractions of a second, just for you.